Our video tutorial today, I will explain all the components of a galvanic cell. A galvanic cell, also known as voltaic cell. So I'm going to write the title here, galvanic cell, also known as voltaic cell. This is an electrochemical cell that converts chemical energy into electrical energy. And this means that there's a chemical reaction that's going to take place, and as a result of this chemical reaction, an electric current is generated. Looking at this figure, we find that the components of a galvanic cell is made up of two half cells. One is an anode half cell and one is a cathode half cell. Now in the figure that you are looking at, it's fully annotated and indicated which one is the anode and which one is the cathode. I am going to explain it, and then I'll give you examples of other galvanic cells in which there are no annotations, and I will tell you how you can still know which one is the anode and which one is the cathode. So the most important part when you are looking at a galvanic cell is to know which one is the anode and which one is the cathode. So I'm going to begin first. The anode and the cathode are both electrodes made of metal. So that's an electrode and that's the other electrode. So it's made up of a metal in the solid state. Anode in the galvanic cell is the negative electrode. Anode has the letter N and negative starts with N, negative. Therefore, the cathode is the positive electrode. Now, what happens? There are basic information that you need to know about anode and cathode, whether the electrochemical cell is galvanic or any other type like electrolytic. Always at the anode, there is an oxidation occurring, and at the cathode, there is a reduction. And an oxidation means loss of electron. So again, I'm going to write here. At the anode, there's an oxidation, and the metal loses electrons and turn into a solution, into an ion. So for more clarity, I will say turn into an ion. So for example here, looking at this anode, which is the copper, it's the copper metal turning into copper ion. It's the copper metal turning into copper ion. Now when I look at this, we add electrons to the copper 2 ion since these electrons are lost. Now, I'm going to explain also in this video what happens later on, what happens if more and more copper ions accumulate in this half cell, in the solution of this half cell. So as you can see here, you have a copper electrode, anode, immersed in a copper solution. So in the solution as well, there are other ions of Cu2+. And now every time the metal loses electrons, it turns into Cu2+. In other words, the metal itself is consumed. And that's why when we look at the anode after a while, we find that the mass of the anode decreases because the metal is used. It turned into ion. So at the anode, the metal loses electrons. It turns into an anion, a negative ion. Also, the anode electrode is the one that loses mass, reduces in mass. So after a while, the anode electrode becomes less in mass. Now I'm gonna come back to this part in few minutes. Meanwhile, when the electrons of the copper metal were lost, they travel through the electric current, electric wire, to reach the cathode. So when the electron reaches the cathode, they reach the solution. So who catches these electrons? The solution at the cathode catches those electrons in order to turn and form more metals that will be deposited at the cathode electrode. So again, at the cathode, we have here the silver solution gaining those electrons coming from the anode electrode and changing into silver solid. So here, by the end of this reaction, we will find that the cathode electrode gain electron and gain mass. The mass gets bigger because more and more and more silver is formed. And from this solution, the silver ions that were present became less because they are consumed in order to form more metal. Now, again, I'm going to write here anode. It's the solution receives the electron, gain the electrons coming from the anode to produce more metal. In our case here, more silver. The cathode is the electrode that gains mass. So the electrode becomes bigger. So anode loses electrons. It's where the oxidation takes place. It's the negative electrode loses electrons and the mass of the anode reduces. Cathode, it's the electrode that gains electron. It's the electrode that has a positive sign. It's where the reduction takes place, gain electron, and eventually the mass of this cathode becomes bigger. Now, during this process, there is an important component of the galvanic cell called the salt bridge. The salt bridge is made up of positive ions we call cations, positive ions, and negative ions that we call anions. Now, the salt bridge, it keeps or maintain the cell neutrality. It balances the ions inside, the two half cells. So let's go back in here. As I mentioned here, the copper metal loses electrons and give me more and more and more copper ions, Cu2+. So there's kind of increase in the positive ions inside the anode half cell. So this creates a positive charge. So therefore, in order to maintain the balance, the salt bridge will send toward the anode the negative ions. Or in other words, we can say that the negative ions or the anions, also called anions, they migrate in the salt bridge towards the anode. Also, at the same time, in the cathode, since Ag plus in the solution, all the ions of silver ion that are in the solution are being consumed. They are taking the electron that came from the anode and they changed into metal. So there's a consumption, there's a reduction in the amount of positive ions inside this cell. Therefore, the salt bridge will send towards the cathode the positive ions that are inside this bridge. Or in other words, we can say that the positive ions migrate towards the cathode. Please note that the ions, the positive cations and the negative cations, they only flow through the salt bridge. And it's the electrons that flows from outside the salt bridge. They flow through the electric wire from anode to cathode. All of this happen at the same time, and when the anode loses electrons and the cathode gain electrons, and the ions in the salt bridge migrate, at that point an electric current is generated that flows. The current goes in the opposite direction of electrons, and the current flows from the cathode to the anode. So, as a result, anode, it's the negative electrode. It's where oxidation takes place. It is a loss of electrons. The metal loses electron. Let me write here. The metal electrode is the one that starts reacting, and it's the one that loses electrons and loses mass as well. It reduces in mass, this anode, and the negative ion called anion in the salt bridge migrates towards it. So the negative anions migrate toward this electrode. Cathode, it is the positive electrode. It's where reduction takes place. It's the solution that gain the electrons to form more metal on the electrode. It gains mass, and the cation, meaning the positive cations, the cations inside the salt bridge, migrates to it. Migrates to it. I hope that this is clear. Now, another important part in the galvanic cell, I'm going to erase this to have more space. So another important part in the galvanic cell is the cell reduction potential. Sometimes from the reduction potential, I can know that this is an oxidation occurring that's going to happen, or this is the anode and this is the cathode. Now, looking at these two given reduction potential, the electrode is always written in the reduction equation form. So it's always the ion to the metal, the ion to the metal. But it's up to you based on the it's based on the voltage given. We will know then which one is the anode and which one is the cathode. The one having less voltage will be the one playing the role of the anode, and therefore it's the metal that's going to give the ion, and the other one is going to be the cathode having the higher voltage. This is going to be the cathode where reduction takes place and the ion gives the metal. Now looking at this, the metal starts reaction. So between copper and silver, if I want to compare silver metal and copper metal, I will say that copper is more reactive than silver, because copper is going to start losing electrons. Copper is going to start losing electrons and turning into copper 2+. So copper will get oxidized. Copper is a stronger oxidizing reducing agent. So copper is going to be oxidized and it's a stronger reducing agent. Now, looking at Ag+, it's the one that's going to give me the silver metal. So Ag+ will undergo a reduction. So it's a stronger oxidizing agent. Or I can simply say silver metal is less reactive than copper metal, because copper is the one that's going to start the whole process. Now, sometimes they ask you to write the cell notation. So the cell notation and also the overall reaction, I'll mention these two. The cell notation is an abbreviation to the galvanic cell. It is represented by the anode solution, and then cathode, cathode metal. So it means what happens here? You put the salt bridge, which is indicated by those two vertical lines. It is the copper at the anode that's going to turn into copper solution. So you write it like this. And it is the silver solution that's going to turn into silver ion, so silver metal. Always don't forget to put the physical states. So that's the cell notation. Now from this cell notation, I can also write an equation. Copper plus silver, copper plus silver gives copper solution plus silver metal. Now, of course, this equation needs balancing. And when we look at the two half equations, we see that this one has 2 electrons. So we are going to multiply this by 2 because the electrons transferred should be equal. The electrons lost should be equal to the electrons gained. So it is 2 by 2. So that's the overall redox equation. And the last part I am going to explain is if we want to calculate the potential, the voltage of the cell, there's a formula that we always apply. It's the E cathode minus E anode. And if these voltages are given, like for example in this case, it is 0.80 minus 0.34 voltage. And the answer in volt. So 0.8 minus 0.34, that's a 0.46 volt. Let's look at other examples. So for example, in this one, there are no indications where is the anode and where is the cathode. However, by looking at the electron direction, the flow of electron, I can deduce that this is the anode and this is the cathode. Why? Because the electron, they always flow from anode to the cathode. So this is a sign on this cell saying that this is the anode and this is the cathode. Now let's look at another example. There are no signs on this galvanic cell to indicate whether the cobalt is the anode or the cathode, and also about the lead. However, the standard reduction potentials are given. So we look at the voltages of these two half cells. We have Pb2 plus Pb with a voltage of negative 0.12 volt, and cobalt to cobalt negative 0.28 volt. The higher number is the one that requires less energy to occur. So this one is going to play the role, is going to be at the cathode. And the one with the less voltage is going to be the anode. And since at the anode we have the most reactive metal, so it's cobalt that's going to give the solution and the lead 2 plus that's going to receive those electrons coming from the anode. So here, number of electrons lost and gained will be the same. So we can say cobalt giving cobalt 2 plus and lead solution giving lead metal. So this is going to be the anode and this is going to be the cathode based on the voltages. Electrons are going to start flowing from the anode to the cathode. The current is going to be in the opposite direction. This is the electrode that's going to lose electrons and reduce in mass, and this is where oxidation is going to occur. Cobalt turning into cobalt plus and 2 electrons. And here this is the cathode. This is where electrons are gained. It's the one that's going to increase in mass. And this is where reduction will take place. This is the positive electrode, and this is going to be the negative electrode. And finally, the positive ions from the salt bridge are going to migrate towards the cathode, and the negative ions from the salt bridge are going to migrate towards the anode. One last example in this video tutorial. This time there is an indication. They are indicating the sign of the electrodes also. I can see the migration of the ions. So I'm gonna deduce that this is the cathode and this is the anode. So if I am going to write the cell notation, it's the metal that's going to give Zn2 plus. So Zn metal giving Zn solution, and it's the solution of copper that's going to form more copper metal. If we want to write the redox reaction, it's the zinc giving Zn2 plus 2 electrons. That's the oxidation, and that's the reduction of copper. We say that zinc is the more reactive metal. And here's the overall equation. Redox reaction. Thank you for listening.